I hope you are fine. So today we are gonna solve the problem of the day for not problem of the day but LeetCode 75 problems for binary search. We have just solved the problem for heap priority queue. Now we are gonna solve the first problem of the binary search. Let's get started. The problem is an easy type of problem. Guess the number higher or lower, right? So we are playing a guess game. The game is as follows. Pick a number from 1 to n and you have guess which number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher or lower, right? You call a predefined API int guessed, okay, which return 3 possible result. -1, your guess is higher than number I picked. Okay, your guess is lower than number I picked, and your guess is equal to the number I picked. Return the number that I picked. So so as you can see, guys, this is just another type of a problem simply from binary search. We just have to do is what we have to do. So if I hope you guys are aware about the binary search. If you're not aware about the binary search, it's a divide and conquer type of algorithm in which we have given a range, a sorted range with start I till end I, and we have to find a number in between this range, right? So okay, we have a range from 1 to n and we have to find a number in between this range. What we can do, so the first native approach is we have to start from 1 and we can iterate. Okay, it is 1, it is 2, it is 3, it is 4, it is 5, it is 6, it is 7, it is 8, 9, 10, 11, and so on and so far, and somehow and somewhere we will find that number, right? So that will take, so this is not a, that is not a binary search, that is a linear search. Linear search, that will be like starting from the start I and iterate one by one till end I and find the number in between. So the time complexity is nothing but O(n), right? So that is a linear search, but it is obvious that the range is sorted, right? We have given a range, and of course we can assume that range is sorted, and we cannot assume it is a fact that 1 to n numbers are sorted. So that is the privilege we have in this question. So we can use that and we can implement the binary search. So binary search is a type of divide and conquer algorithm, right? In which, okay, we have a range and we can assume a number in between the range. We can say that, okay, let's say we are given with 1 से लेके 10 तक. So okay, we can say, okay, we can guess that your number is 5, right? Your number is 5. It's just a plain guess, right? So the API will be called, and it tells that, okay, the number is greater than 5. My number is greater than 5. Okay, so now our range get reduced. You see, our range get reduced in just one process, right? We don't have to process 5 times, and we don't have to call API 5 times to get into the conclusion that our number is greater than 5. We just have to call the API one time now. Okay, so the number is greater than 5. Good. So okay, let's assume the number is 7. Okay, 6. So we have we get the response that, okay, the number is smaller than 7. Okay, so it's obvious that it is greater than 5 and is smaller than 7. So Yeah, it is 6, and we will return 6. Right. Now you see, we have got this solution in just 2 API calls, or we can say 3. So we will call them, if the number is 6, okay, yeah, number is 6, we will return. What about the linear search? We have to call API 6 times, so we will reduce, and in every API call we reduce our range to the half of its previous range. So the overall time complexity will be log n, because every time we are dividing our range in the half. So that is a divide and conquer type of algorithm, and let's implement this. So guess number self n, right? So we have start, which is 1, we have end, which is nothing but n, right? So we have mid, which is nothing but start plus end by 2. So while start is smaller than end, we are reducing a range. What is it? What is the API int guessed, right? Call guess mid, right? Mid is nothing but start plus end by 2. Guess mid. So okay, so response is nothing but guess mid. So if response is equals to -1, that means your guess is higher than the number. So guess is higher, that means we have to reduce our range from the right side. That means end is nothing but mid -1, right? Else if response equals to 1, that means we have our guess is lower. That means number present at the right side, so we will make start equals to mid +1. else return mid. Else we got a 0, that means number is equals to pick, that means return number which is mid. Okay, and this is how we return mid here, because in any time we got something like okay, start we got something like, okay, we have started in, so like we got a range which is this, right? So like 1 2 3 4 5, and somehow we got that our started point is on 3, our end is pointed on 3, that means 3 is the final number, right? So this is what we are going to do. हेलो, मैं उसमें हूँ, आता हूँ बस एक मिनट में आ रहा हूँ. हाँ चलता हूँ, मैं फ्री हो गया. ठीक है. Okay, what is this? So we have and pick is 2. What I'm returning? Okay, so sorry guys, you have to I have to make this equal also, because yeah. So what I was doing is I was saying that start from -1, start from 0 and end on 1, right? So I will return 0, but that is not the case. Both can be possible, right? So I have to process that also. So okay, let's submit this. This will got submitted by now. So yeah guys, as you can see, we have solved this problem. Let's see the most optimized one. left right. If I left not equals to right as this, guess 0 return as 1. Yeah, that's it. Okay, just by doing this I have but this is just a few milliseconds. So that's all from this solution. I hope you understand my approach. Thank you for your time. Thank you for your patience. If you have any doubt, you can ask in the comment section. Thank you.